And LSA1 carry what informations? LSA1, router LSA. Router LSA carry the state of link, state of links. Like in this scenario, in the headquarter, router 1 is going to generate LSA1 to LSA1 because router 1 is connected with two different area. With area, this interface is connected with area 0 and this interface is connected with area 1. So router 1 is going to generate two number of LSA1. One LSA1 for area 1 and one LSA1 for area 0. Router 1 will flood LSA1 of area 0 in this domain and LSA1 of area 1 in this domain, right? And in the LSA1 it will store information of link, right? Like link is f0/0 where network, which network is running there, right? What is the cost on that network, what is the IP address, my IP address on that link, these informations, right? All routers are going to generate LSA1 and LSA1 carry link information, router LSA. Now LSA2. LSA2. Hope LSA1 is clear, guys. And you also know that a router can design the topology with the help of LSA1. Router can design entire topology with the help of LSA1. Correct? So I am not going to discuss LSA1 again. Let me discuss LSA2 first. Where is the request? LSA2. LSA2 is network LSA. And guys, always keep in mind one thing, that whenever change will occur in the LSA1, router will execute SPF algorithm. Yesterday we had seen that, right? Whenever change will occur, whenever a network will goes down or any network will come up in the ospf domain, router is going to update their LSA1. It will increase sequence number with 1 and after that it will execute SPF algorithm. So whenever change will occur in LSA1, routers are going to execute SPF algorithm. Correct? Command to check the SPF algorithm execution time is show IP ospf. Right? So anyone can ask you, like interviewer can ask you that whenever change will occur in the ospf, what will happen, or how routers are going to update their database. So routers are going to update their database with the help of sequence number, and then it will flood the updated LSA to their neighbors. Again, when neighbor will receive LSA1, first it will check the sequence number. If sequence number is updated, then only it will open that LSA, otherwise it will discard it. Let's suppose a router have already LSA1 from a neighbor from 1.1.1 with sequence number 5, and again router is receiving same LSA1 from 1.1.1 with same sequence number 5, right? Router will come to know, oh, this is not updated information. I have already updated information, right? So router will discard it. But if sequence number is 6, router will come to know, okay, I have the LSA1 of 1.1.1 with sequence number 5, and this LSA1 is with sequence number 6, higher sequence number. That means my database is not updated. Let me update my database. Getting my point? Right? So you can say whenever router will receive LSA with higher sequence number, then router will update their database. It will execute again SPF algorithm. Problem is what? problem of LSA1 in multi-access network, like in this scenario, guys, in the headquarter. What is the issue? Duplicate information, correct? Duplicate information, like if any link will goes down on router one is going to share their LSA1 to their all neighbor. Their neighbor means router 4 is also going to send to their neighbor. So that's why we come up with which concept? To reduce this issue, to reduce this flooding, to reduce this duplicate message flooding, we come up with DR and BDR. So in the multi-access segment, one router will become DR, one router will become BDR, and all other router will become DR other. So now question is, which router will become DR? Highest priority. Highest priority. And by default priority is 1, so priority will tie. So on the basis of highest order ID, router will perform DR and BDR election. So in this scenario, router 1 have 1.1.1.1 router ID, router 2, 3, like 4 have 4.4.4. So tell me which router will become DR? Router 4. But if you will enable ospf on all router within 40 seconds, then only router 4 will become DR. Let's suppose you have configured enable the ospf on router number 1, right? And router 1 have not received any hello message with higher router ID within 40 seconds, then router 1 is going to declare their self as DR. And once a router will become DR in the network, once a router will become DR in the multi-access network, role of DR is not going to be, guys, changed. That router will be DR, even it will receive hello message with higher router ID, doesn't matter. Now the question is here, just wait. Yes. Now the question is, R1 is the router, DR router. Let's suppose R1 is the DR router. And guys, if I want to configure R1 as a DR, like R1 should be DR always, what I can do? I cannot modify the router ID, right? I can configure the higher priority here, right? So let's suppose I have configured priority 10 here on router number 1. So now router 1 will be my DR, and let's suppose there is no BDR, right? So router 1 is going to form full neighborship with all other router in headquarter, and all other routers are going to form neighbor without adjacency, means still two-way. Now how DR other routers will came to know how many routers are there in this domain? This is the reason why DR router is going to generate LSA 2. As I told you, all odd number LSA are used to share network information, and even number LSA may like router LSA 2, LSA 4, LSA 6, these LSAs are used to share information of router. So LSA 2 is generated by DR router to share connected router information in the network, right? To share connected router information in the network. So LSA 1 will carry link information, and in the LSA 1 of router 1, advertising router ID will be 1.1.1, link ID will be also 1.1.1, and then there will be link information like link 1 network 192.168.1.0 submit mask /24, and then cost on this link is, let's say, 1. This is LSA 1 of router 1 in area 0, for area 0. Now LSA 2. See, router 1 is the DR router, so DR router is going to generate LSA2 as well. So in the LSA2, it will carry what information? Again in LSA2, link ID and advertising router ID will be there. All LSAs will carry these two information. So link ID will be, sorry, router ID will be the router ID of advertising router. Advertising router ID will be the router ID of router 1, 1.1.1.1. Then link ID. Link ID will be the IP address of DR router. Advertising router ID is 1.1.1.1. Link ID is going to be what? 192.168.1.1. IP address of DR router. Done, guys. After that, there will be information about connected router, attached router, attached router. Attached router are 1.1.1.1, 2.2.2.2.2, 3.3.3.3.3, and 4.4.4.4. This is what LSA2 of router 1, and then DR router is going to forward it to all other DR other router, means router 4, router 2, router 3. And this is how DR other router will came to know about this connected router, attached router. Is it clear? Is it clear, guys? The use case of LSA2. If you want to verify it before starting LSA3, let me do one thing. Let me access these all routers here. First of all, lock the lab. R1, R2, R3, and R4. R1 should be my DR router because R1 is high configuration router. So on router number 1, I am going to configure higher priority. Config T interface F0/0 say no shut, and IP address is 192.168.1.1, 255.255.255.255, sorry, 255.255.255.0. Done. See, in the headquarter, I am going to use this subnet. And guys, between routers, like between router 1 and router 5, I will use 15 network. Between router 4 and router 7, I will use 47 network. Between router 7 and router 8, I will use 78 network, like this. And on all routers, like on router number 5, I am going to create some loopback. And on those loopback interfaces, I will run this network, like on router number 5, 50.1.1.0, 50.1.2.0, like this. On router number 10, I can create loopback like 100.10.1.1.1. This is my IP schema. Okay. Now, IP ospf priority. Let's say 10. By default, priority is 1. Here I have configure priority 10. Exit. Router ospf 1 and router ID 1.1.1.1. Then I need to enable ospf here on F0/0. So F0/0 say IP ospf 1 area 0. And I don't want to participate any other router in DR and BDR election. So what option I have, what I can do on router number 2? Let's say I don't want to participate router 2 in DR and BDR election. IP address 192.168.1.2.255.255.255.0. I can configure priority 0 here, right? So say IP ospf priority 0, and then network router ospf 1 and router ID 2.2.2.2. And then I can use network command, or simply I can enable ospf on interface, say IP ospf 1 area 0. Now this router will not participate in DR and BDR elections. So do so IP ospf interface f0/0 include priority. You can see priority over here is 0. And we have now neighborship between router 1 and router 2. We have ospf neighborship. Do so IP ospf neighbor. So 1.1.1 is neighbor and 1.1.1 is DR, and state is guys full. Now go to router number 3, and on router number 3 also say interface f0/0, and first of all router ospf 1 and router ID 3.3.3.3. Let me configure the router ID, then go to interface f0/0, say no set, and IP address 192.168.1.3 255.255.255.0 IP ospf priority 0 and IP ospf 1 area 0. I have advertised it in area 0. Now soon router 3 and router 1 will form ospf neighborship. Now you can see the log message. Go to router number 4 now, config t router ospf 1 and router ID 4.4.4.4. Exit interface f0/0 no set and IP address 192.168.1.4 255.255.0 IP ospf priority 0 and IP ospf 1 area 0. Now here also you will see ospf neighborship. And now let me show you the LSA. On router number 1, even in the headquarter all router will have same ospf database, right? So on router number 1 you can verify. So IP ospf database. How many LSAs 1 are there? How many LSA 1 are there, guys? How many LSA 1 are there? Means router LSA 4. 1 of router 1, 1 of router 2, 1 of router 3, 1 of router 4. You can open any LSA 1 in detail, but today we are not going to focus on LSA 1. Today we are going to focus on this LSA, network LSA. How many network LSA are there? Only 1. Who is generating advertising router ID? DR router, right? So advertising router ID is the router ID of router who is advertising that LSA, and link ID is IP address of DR router. Now let me open network LSA in detail. So IP ospf database, then network, and as I told you we will always open LSA in detail with the help of link ID. So 192.168.1.1. What informations are there? Same. So LSA 2 is used to share connected routers information. LSA 2 is used to share connected router information, and DR router will always generate LSA 2, and this is what LSA header. In the LSA header, see informations are advertising router ID and link ID. Link ID is the IP address of DR router, and advertising router ID is same like LSA 1. So is it clear? LSA 2 is clear? Yeah, see, you will have same output. So IP ospf database. First of all, see here also we have 4 LSA 1 and 1 LSA 2. Now I am going to open LSA 2 in detail. So IP ospf, and see on router number 2 also. Which router is generating this LSA? LSA 2. R1 means DR router. So IP ospf database network and 192.168.1.1. See, we have same information, right? Guys, ospf is a link state routing protocol. That means all router will have information of entire topology, entire network. Means database is going to be identical, same on any router. On router number 3 also you can see. So IP ospf database. So IP ospf database. We have same database, right? And so IP ospf database network and 192.168.1.1. Done. On order number 4, show IP, OSPF, database, network LSA and 192.168.1.1. Same information, right? So now here anyone can ask you, tell me in this scenario in the headquarter, how router number 2 or DR other routers will get to know how many connected routers are there. So answer should be DR router is going to generate LSA 2. Done. Done, boss. So LSA 1 generated by every router in OSPF domain. LSA 2 generated by DR router to share a test router information, and LSA 1 to share link information. Clear? LSA 3. Can I move to LSA 3? Any question? Now try to understand the LSA 3. Guys, I have this network R1, R2, R3. LSA 3 is odd number LSA, means LSA 3 is used to share network information. I have this topology, router 1, 4 routers are there, router 1, router 2 is connected with router 1 and router 3 is connected with router 2 and router 4. Let's say this is R1, R1, R2, R3, R4. Don't worry, I will give you real-time example as well. Like you can see in this company network, right? This is, let's say, company of XYZ or pmnet.com, who have one data center and 4 branch offices. Now in this scenario, router 1, router 2, router 3, router 4, all routers are connected with LAN network. Here we have one LAN, here we have one LAN. Now I am going to ask you a question and you will be answering me. Here on R1 I am running one network, that is 192 dot, or let's say 10.1.1.0. What happened? Okay, on order number 1 my LAN network is 10.1.1.0/24. On order number 4 my network is 40.1.1.0/24. 40.1.1.0/24. What should be network type between routers? What should be network type of OSPF, guys, between routers? Point to point, so that it will not perform DR and BDR election, because DR and BDR is not required here. Now let's suppose this is these two routers, router 1, router 2 and router 3 belongs to area 0, and router 3 and router 4 belongs to area 1. If you are thinking why Praful I will configure scenario like this, like I will place router 3 and 4 in different area and router 1, 2, 3 in different area, just wait, don't worry, we'll give you real time scenario, right? But for now, just suppose this is area 0, this is area 1. Area 0 is the backbone area, and any area except area 0 is the regular area. Now, how router 1 is going to share network information, means send network to their neighbor to router number 2? With the help of which LSA? And before that, tell me how many LSA will be there in the database of router 1? If I will execute command show IP ospf database, how many number of LSA 1 will be there, guys? Not 4, because LSA 1 of router 4 can reach to router number 3 only. It cannot cross the area. The limitation of LSA 1 is LSA 1 cannot cross the area. Yes, total number of LSA 1 will be 3 in the database of router 1, right? LSA 1 of router 1, LSA 1 of router 2, LSA 1 of router 3. Router 4 will also have 2 number of LSA only. LSA 1 of router 4 and LSA 1 of router 3. Router 3 will have how many number of LSA? 5 number of LSA 1. LSA 1 of router 1, LSA 1 of router 2, LSA 1 of router 4, as well as 1 LSA 1 of router 3 in area 0 and 1 LSA 1 of router 3 in area 1. So total number of LSA will be 5, right? So when router 1 will send LSA 1 to router number 2 to their neighbor LSA 1. So with the help of this LSA 1, router 1 is going to share this network information 10.1.1.0. Router 2 will also send the LSA 1 to router number 3. So router 3 will get this network information 10.1.1.0/24. In the same way, router 4 will send LSA 1 to router number 3 and it will share this network 40.1.1.0/24. Now, can router 2 receive 40 network? No. And guys, in this scenario, we will not have any LSA 2 in the database of any router because there is no DR and BDR. But in this scenario, router 3, router 1 don't have 40 network information. In the same way, router 4 don't have 10 network information because of LSA 1 limitation. Now question is how these two networks are going to communicate with each other. How these two routers are going to communicate with each other, right? Is issue clear? Is issue clear? Problem done. Now try to understand types of router in ospf. Types of router in ospf. So guys, we have some types of router in ospf. Let me write here the name of each. First one is router types. First one is backbone router. Router whose all interface belongs to area 0. Router whose all interface belongs to area 0. So tell me which router is backbone router in my scenario? Router 1 and router 2, because all interface of router 1 belongs to area 0 as well as all interface of router 2 belongs to area 0. Second type of router is internal router. Now tell me which router is the internal router, and definition of internal router is router whose all interface belongs to regular area. There are two types of area, backbone area and regular area. Area 0 is the backbone area and all area except area 0 is known as regular area. So the router whose all interface belongs to regular area, right, means all interface belongs to area 1, 2, 3, 400, 100, 500. So tell me which router is the internal router? R4 na bro. R3 have one interface in area 0, one interface in area 1. Router whose all interface belongs to regular area, R4. Third type of router is ABR router. Definition of ABR router is router whose at least one interface belongs to area 0 and whose at least one interface belongs to any regular area. That router is known as ABR router. What I am saying, router whose at least one interface belongs to area 0 and at least one interface belongs to any other area. So which router is the ABR router in my scenario? R3, because R3, one interface of R3 belongs to area 0 and one interface of R3 belongs to area 1. So R3 is my ABR router. Fourth type of router is ESBR router. ESBR router. Definition of ESBR router is router whose at least one interface belongs to area, not area, whose at least one interface belongs to ospf and at least one interface belongs to any other domain, like in EIGRP, ospf, BGP, ISIS. Router whose at least one interface belongs to ospf and one interface belongs to any other domain, that router is known as ESBR. And guys, keep in mind always, ESBR router is going to generate LSA3 to make communication possible between two different area. Like here issue is these two different area are not able to communicate with each other. These two area are not able to communicate with each other because of LSA1 limitation. LSA1 of area 0 cannot enter in area 1. In the same way, LSA1 of area 1 cannot enter in LSA 0. So to make communication possible between these two area, we need what? ABR router. If there is no ABR router, that means there is no any router who is going to generate LSA3, right? So always keep in mind, between two area, ABR router must be there. So let's say if I will configure this area as area 2. Now is there any ABR router, guys? Is there any ABR router? No. Now there is no ABR router. Now can these two areas communicate with each other? Never. Never. Not possible. Because ABR router is responsible to make communication possible between different area with the help of LSA 3. With the help of LSA 3. Done. Now what ABR router will do? See, once we will configure one interface of this router in area 0 and one interface of this router in area 1, this router will start acting as ABR router. Once this router will become ABR router, it is going to generate LSA 3. It will generate two number of LSA 3 because this router is connected with two different area, LSA 3 for area 0 and LSA 3 for area 1. In the LSA 3 of area 0, it will include all network information of area 0, and how router 1 have information about the all network information with the help of LSA 1. Router 1 have this 10 network information with the help of LSA 1. So it is going to install that network information in their LSA 1, which is 10.1.1.0/24. In the same way, it will generate one LSA 3 for area 1, where it is going to install all prefixes of area 1, which is 40.1.1.0/24. Now ABR router is going to send LSA1 of area LSA 3 of areas 1 into area 0 and LSA 3 of area 0 into in area 1. This is how router 1 and router 2 will get 40 networks and router 4 will get this 10 network information. Clear? So LSA 3 will be generated by ABR router. ABR router to share inter area prefixes. Now if you are thinking that ABR router is going to generate LSA 3 and in LSA 3 it will again include the entire information, then no guys. Between area, ospf is also a distance vector routing protocol. Means in the LSA3, routers are going to carry only network information, not the detailed information, right? With the help of LSA1 and LSA3, router 1 cannot design the entire topology. Router 1 cannot design the entire topology. Router 1 can view this topology only, right? So OSPF is a link state routing protocol within area. Between area, again OSPF is a distance vector routing protocol. Clear? So guys, in my scenario, tell me which router is there any backbone router? Is there any backbone router in my scenario? Which router is backbone? Which router is the backbone router? If yes, then tell me which router is the backbone router? R4. See, one interface of R4 belongs to area 0 of OSPF and one interface belongs to EIGRP. That means router 4 is the ESBR. Yeah. Is there any backbone router, guys? No. How many ABR router are there? ABR. No. No. Okay, how many internal router are there? How many internal router are there? Internal means whose all interface belongs to regular area. That yeah. See, this router 5 have all interface in area 1. That means this is internal router, this is internal router, this is internal router. That's it. 3 internal routers are there. How many ABR are there? Router 1, because router 1, see, one interface of router 1 belongs to area 0 and one interface belongs to area 1. So ABR. Router 3 also ABR. Router 2 also ABR. So 3 ABR, 3 internal router, 0 backbone router. So now tell me, in the database of router 1, how many LSA1 will be there? 4? No. LSA1 of area 0 as well as LSA1 of area 1, area 2, area 3. Never, right? Because this LSA is not going to cross the area. So guys, router 1 will have 5 number of LSA1 in their database. 5 number of LSA1, 5 or 6? Because router 1 is going to generate 2 LSA1. It will receive 1 LSA from router number 4, 1 from router 2, 1 from router 3 and 1 from router number 5. 6, correct? How many LSA2 will be there? LSA2 means network LSA. DR router is going to generate. How many DR are there? Only one. So only one LSA2 will be there. How many LSA3 will be there? How many ABR router are there, guys? 4 or 3? 3, right? So 3 number of LSA3 will be there, right? Now LSA4. LSA4. Now try to understand again one issue. Okay, router 3 is the ABR router in my scenario. That means router 3 is going to generate LSA3 in this area, LSA3, And in the LSA3 it will share this network information 40.1.1.0/24. And as I told you, LSA3 only carry network information, right? Means 40 network will be there. In the same way, router 3 will forward one LSA3 to router number 4 also, and it will install this network information in this LSA 10.1.1.0/24. Now when router 2 and router 1 will receive this 40 network information, how routers are going to calculate metric for the destination network? How routers are going to calculate metric? This is the issue, right? So guys, when ABR router will generate LSA3, it will also include the metric with the prefix. Let's suppose router 3 is saying, okay, I am sharing this network information in area 0 and metric is 1. Now router 1 and router 2 need to calculate metric for the destination network. So router 1 and router 3 need metric to reach ABR router, because who is advertising this network information? ABR router. And what is the metric? Advertised metric by ABR 1. If I will calculate the metric to reach ABR router, that means I can find the metric to reach the destination network. Let's say metric to reach ABR router is 2. Okay, now I can calculate the metric for destination network, because ABR is generating network, sharing network with metric 1. That means metric from ABR router to destination is 1 and metric from me to ABR is 2. That means total metric to reach in destination network is 3. But who will tell to router number 1 who is your ABR? Who will tell who is the ABR router? So that's why we come up with LSA 4. That's why we come up with LSA 4. Guys, LSA 4 will be generated by again ABR router, but this is even number LSA. That means it is not used to share network information. Then what is the use of LSA 4? LSA 4 is used to share the information of ABR router, right? So router 3 is going to generate LSA 4 to share ABR information that I am ABR router, right? Yeah. Okay, I have connected. Thank you. Okay, done. So LSA3 generated by ABR router to share network information, inter-area network information, and LSA4 again generated by ABR router to share the information of ABR router, right? Who is the ABR router? Clear, guys? LSA3 is summary LSA, right? LSA3 is summary LSA. And if I will talk about the LSA1, in LSA1 we have some flags, flag bits, right? First flag bit is B bit, then E bit, then V bit. V bit is used for virtual link, right? We'll discuss it later. For now, let me discuss B bit and E bit. Guys, B bit means ABR router, right? Whenever a router will receive LSA1 with B bit on, that means it will come to know that okay, this is the LSA1 of ABR router. If a router is receiving LSA1 with E bit on, router will come to know okay, this is the ASBR router. So ABR router will always on B bit in their LSA1. ASBR router will always on E bit in their LSA1. So with the help of this bit, router can identify ABR router. Like see, in this scenario, ospf is running on all routers. If I will capture this link, let me capture any link. and I want to show you the LSA1. How I can show you LSA1? Because routers are not going to send LSA1 periodically, so it will be not sending LSA1. Now if I will add any network information on router number 1, then definitely it will generate LSA1, right? So let me do one thing. Let me create one loopback on router number 1, and I'm going to advertise that loopback in area 0. So interface loopback 1, say IP address 10.1.1.255.255.255.0, and say what? Node set not node IP ospf 1 and area 0. Hit enter. Are you able to see LSA1? Here is the LSA1, guys, right? This is header advertising router ID. And now let me open the LSA1. See, type 1 LSA. In the LSA1, see the flag field. Where is the flag field? Here are the flags, right? And B bit is off, E bit is off, V bit is off. All bits are 0. So router sent a LSA1 with all bits off by default. But once this router will become ABR router, it will start sending the LSA1 with B bit on. Once this router will become ABR, it will start sending LSA1 with B bit on. B bit means area border router, ABR router. ABR router. Now again I am going to remove this loopback, say no interface loopback 1. Again it have generated the LSA1, right? Done. Now I am going to make this router ABR. For now, show IP protocol. You can see there is no any information about ABR. Correct, guys? But once I will advertise this interface F1/0 in area 1, this router will become what? ABR. Right? And show IP ospf database. In the database, now we have only two types of LSA, LSA1 and LSA2. Now let me add this link, interface F1/0, interface F1/0. Say no set and IP address. On this interface, guys, as I told you, between router 1 and router 5, I'm going to use 15 network, 15.1.1.1 and 255.255.255.0. I'm going to advertise it in which area? In area 1. I'm going to advertise it in area 1. So command is IP ospf 1 area 1. Here is the caption. Update message LSA1. This is LSA1. Let me open the LSA1. See, first information here. B bit is on. Yes, right? That means this router is ABR router. Now when router 2, router 3, router 4, these routers will receive LSA1 of router 1. This router will came to know router 1 is the ABR router. Yes or no? So simply you can check on other routers, like on router 2, 3, 4 on this router. Before that, on router number 1, if you will check protocol command, so IP protocol, so it will show you that this router is now ABR router. What it's saying, it is an area border router. And go to router number 2 and say show IP ospf border routers. So what it's saying, 1.1.1 is ABR router, right? Router 3 also, so IP ospf border router. Okay, 1.1.1 is border router. Router 4, so IP ospf border router. Router 1 is, now you know how this router knows that this 1.1.1 is the ABR with the help of LSA1. With the help of LSA1. And now if you will check the ospf database, so IP ospf database, now you can see In the database, we have some new LSA. We have some new LSA. These are LSA1, the previous entry. This is LSA2, network LSA. Now you see the new LSAs. Which LSA is it? It is summary LSA. Who is generating? Advertising.id 1.1.1. Link ID 15.1.1.0. So guys, LSA 3 used to share network information. See, router 1 is sending inter area network information. This is the network of area 1. How router is sending the network information of area 1 in area 0 with the help of summary LSA. So in the summary LSA, advertising router ID will be again the router ID of router who is advertising that LSA, and link ID will be prefix information. Prefix information, and then LSA 4. Here is the LSA 4. LSA 4 is not there. Actually, LSA 4 is used to share the information of ESBR order, not ABR order. So we don't have LSA 1. Actually, this is router LSA of area 1. This is LSA 3 of area 0. For area 1, you can say it is generating LSA 3 for area 1, where it is sharing area 0 network. So router 1 have generated two number of LSA 3, one for area 1 and one for area 0. For area 0, in the LSA 3, you can see there is network information of area 1, and in the LSA 3 for area 1, there is network information of area 0, right? So router 1 is sharing now, is generating two LSA 3. Yeah. Which one? 15.1.1.0? Yes. Actually, this is the LSA 3 for area 0. For area 0. See, why router 1 is generating LSA 3 for area 0? To share network information of area 1. Router 1 is generating LSA 3 for area 0 to share this area network information. So link ID will be the network information in area 1. Why router 1 is generating LSA 3 for area 1? To share area 0 prefixes. So link ID will be all the prefixes in area 0. Router 1 have generated two LSA 3, one for area 0. This is for area 0. For area 0. This is for area 1. Right? And now on router number 2, so IP ospf database. On router number 2 also you can see we have all LSA 1 of area 0, LSA 2 of area 0, then LSA 3. Who is generating? ABR order 1.1.1, and it is advertising which network? 15.1.1.0. Right now we have only one network in area 1. That's why it is advertising, it is generating only one LSA 3. Now how router 2 is going to calculate cost for this network? So simply you can open this LSA in detail. So IP ospf database, and then summary 15.1.1.0. So see, ABR router is advertising this LSA with what metric? 1. And metric to reach ABR router is, so IP ospf border router, metric to reach ABR router is 1. So what will be the total metric? 2. So IP route ospf 15 network, metric is 2. Got it, guys? Now let me access order 5, and on order number 5 I'm going to configure ospf config t interface f1/0 say no set and IP address 15.1.1.5 255.255.255.255.0 exit router ospf 1 router ID 5.5.5.5 and now let me enable ospf over here, say IP ospf 1 area 1. Soon it will form ospf neighborship, and by default network type is so IP ospf interface f1/0 include network. By default network type is broadcast, but network side type should be what guys here? Point to point. So manually you should change the network type here for better stability, better performance. Say IP ospf network type point to point. You have to do same thing on order number 1 also. F1/0 say IP ospf network point to point. Now go to order number 5 and see we have neighborship, and so IP ospf database. How many LSA 1 are there? 2. One of order 1, one of order 5. How many network LSA are there? 1. This is the previous entry, right? Soon it will remove it because earlier there was DR on the link. So simply you can clear the ospf process, clear IP ospf process, say yes. Wait, soon it will resynchronize the ospf membership. Now you can see so IP ospf database. Now we don't have LSA2 here, right? We don't have LSA2. There are 2 number of LSA1 and 1 LSA3. Who is generating LSA3? 1.1.1 ABR router, right? And which network it is advertising? Area 0 network, right? How to find the cost for this network? Let me check. ABR router is advertising this network with what cost? So IP ospf database, then summary and 192.168.1.0. You will always open database with the help of link ID, not with the help of router ID. Metric is 1 and metric to reach ABR. So IP ospf border router. Metric to reach ABR is also 1. So IP route ospf. Cost metric for this network is 2 total. Correct? Now I am going to create some loopback here on router number 5. Interface loopback 1. IP address 50.1.1.1 255.255.255.0 and say IP ospf 1 area 0 and IP ospf network, let's say point to point. Exit interface loopback 2 IP ospf 1 area. Sorry, I have advertised it in area 0. If you will advertise it in area 0, then this router will also become ABR router. So let me correct it. Interface loopback 1 IP ospf 1 area 1. Interface loopback 2 IP ospf 1 area 1 and IP address 50.1.2.1 255.255.255.0 IP ospf network point to point. Let me get one more loopback. IP ospf 1 area 1. Okay. IP address 50.1.3.1 255.255.255.0 IP ospf 1 area 1 and IP ospf network point to point. Otherwise, by default network type on the loopback interface is loopback. Now interface loopback 2 IP ospf 1 area 2. So IP ospf interface brief. You can see ospf is enabled on all interfaces, guys, right? And so IP ospf database, it have install all link in their LSA. So see total number of link in the LSA 1 of router 5 is 4. Total number of link in the LSA 1 of router 1 is 2. And then LSA 3. LSA 3. Who is generating? This one. This is again Which LSA it is? Router LSA. Router LSA for which area? Area 2. Where is area 2? Is there anything wrong, guys? So IP ospf interface. So IP ospf interface brief. So these all are in areas. Loopback 2 is in area 2. Let me correct it. Interface loopback 2 IP ospf 1 area 1. Let me save the configuration here. Here I have created some loopback. Let me write it down. It will be easy for you. 50.1.1.0/24, 50.1.2.0/24, and 50.1.3.0/24. We have some loopbacks here. Maybe router 5 is also learning this network from their neighbor routers, or it is receiving from any other branch offices or any partner network. So router 5 is going to advertise this network to router number 1 in the form of which LSA? Tell me, this is your question. Router 5 is going to advertise this network information in the form of which LSA? In the form of LSA 1, guys. So IP ospf database. See, router LSA of router 5. So IP ospf database router and 5.5.5.5. See, in the LSA 1 of router 5 we have these all subnets: 50.1.1.0, 50.1.3.0, 50.1.2.0. So router 1 will learn these all network in the form of LSA 1. So here see, so IP ospf database. So this is LSA, router LSA of router 1 in area 0. So that's why here we are not able to see LSA 1 of router 5. But router 1 will have two router LSA. You see, router LSA in area 1. Where is router LSA in area 1? Here is the router LSA in area 1. This is in 0, and router LSA in area 1, router LSA in area 1, right? So in area 1 you can see we have router LSA of router 5. So if you will open this LSA in detail on router number 1, you will get all 50 network information. To verify it, I can say so IP ospf database router and then 5.5.5.5. See, all 50 networks informations are there, right? So whenever router will receive a network information in the form of LSA 1, in that scenario router 1 will have detailed information, right? Means information of cost as well. So router can design the topology. You can see cost is there. And now router 1 is going to advertise these all 50 network information to other routers in the headquarter, like to router number 2, in the form of which LSA? In the form of LSA 3. So IP ospf database. So you can see it is learning all 50 network information in the form of LSA 3. And router 1 is generating how many LSA 3? 4. Because there are 4 subnet in area 1. So if there are 1000 subnet in area 1, router 1 will generate 1000 number of LSA 3. One LSA 3 carry one network information, and ABR router is sending what? Only network information with metric. So IP ospf database and then summary LSA 50.1.1.0. You can see for this network informations are network link state information, what subnet is running there, subnet mask, and the cost. This is cost from ABR to the destination network, from ABR to 50.1.1.0 network, and cost from me to ABR, cost from router 2 to ABR is 1. So IP ospf border router cost to reach ABR is 1. So total cost will be what? Cost which is coming in LSA 3 is 2. And who is advertising? 1.1.1. Advertising router ID 1.1.1, which is the ABR router, and cost to reach ABR is 1. So total cost to reach in 50 network is clear, guys? Clear? Now I am going to show you LSA 4. So first of all, before configuring LSA 4, let me save the configuration on router number 1 also. Save the configuration on router number 2. Save the configuration on LSA router number 3. Save the configuration on router number 4. Save the configuration. And let me finish the configuration of router. I have finished the configuration of router 5, router 1. Let me finish the router 2 configuration. On router number 2, I have one interface in area 3. So interface F1/0 IP address. IP over here is, let's say, 210.1.1.2, 255. Or I can configure 21 as well. Let's say 21.1.1.2, 255.255.255.0, and IP ospf 1 area ID 3. Done. Save it and go to router number 10. Interface F1/0, say no cert, and IP address over here 21.1.1.10, 255.255.255.0, IP ospf 1. And before enabling the ospf, let me configure the router ID, otherwise we cannot change the router ID. Router ospf 1 and router ID 10.10.10.10. Exit interface F1/0 IP ospf 1 area 3. Just wait for ospf neighborship, and we need to change the network type as well. So IP ospf network point to avoid DR and BDR election here. Now on router number 2 also config T and interface F1/0 IP ospf network point to point. Done. Why we don't have neighborship here? So IP ospf neighbor, so IP interface brief exclude unassign. Interface is up, ping 21.1.1.2, but ping is not working. Go to router 2 and show IP interface brief exclude unassign. Okay, this interface is down. Config T interface F1/0 say no set. Write the configuration. Now tell me, router 10 will learn 50 network in the form of which LSA? Now we have ospf neighborship. Yes, guys. So IP ospf neighbor. For router number 10, who is ABR router? For router number 10, who is ABR? So IP ospf border router R2 2.2.2. So who will generate LSA 3? 2.2.2. What is the cost to reach ABR? 1. And tell me how router 10 have get to know that 2.2.2 is ABR router? How router 10 understood that 2.2.2 is ABR router? With the help of which bit? With the help of B bit in LSA 1, right? So router 2 is sending their LSA 1 with B bit on. Yeah? Router 2 is sending their LSA 1 in both area, in area 3 also and in area 0 also with B bit on. By default, OSPF router send LSA1 with all bits off. So in the headquarters, see, whatever edge router we have, those all edge routers are going to either become AVR or ASBR. ABR or ASBR. Now show IP OSPF database. So see guys, router 10 database. How many LSA1 are there? Two number of LSA1 in area 3, right? One of router 2 and one of router 10. How many link are there in the LSA1 of router 2? Only 2. And how many LSA3 are there? These are. Who is generating? 2.2.2.2. 2.2.2.2. Right? So now I can open like 50 network in detail if I want to check. So IP OSPF database, and then I can say summary 50.1.1.1, 50.1.1.0. See, metric is 3 and metric to reach ABR is 1. That means total cost to reach in this network 50 network is total cost to reach in this network is 4. Right? So IP route OSPF for 50 networks, you can see cost is 4. Done. Whenever a router will install route in their routing table from LSA1, then guys it will denote like this O, only O, and after that network 192.168.10.0, like on router number 1. So IP route OSPF. Is there any route with O symbol only? Yes, that means these are route learned by LSA1 and this is the route learned by LSA3. This is the OI, means OSPF inter area prefix, OIA. It's denote with this symbol OIA, OSPF inter area prefix. O means OSPF intra area prefix, means these are the prefix of same area, right? So router 1 have one interface in area 1, right? So for router number 1, these are the prefixes of same area, and this 21 between router 2 and router 10. 21 is running between router 2 and router 1. So it is learning in the form of LSA3, right? And who is advertising? What is the next top IP address? Router 2 IP address, right? Router 2 is the ABR. So IP OSPF border router. You can see 2.2.2 is the ABR router. Now let me save the configuration of router 2. Let me save the configuration of router 5. And let me save the configuration of router 10. Now let's move further. On router number 3, let me take you to R3 now. And let me finish the configuration of R3. Config T, interface F1/0, say no cert, and IP address. So IP address between router 3 and router 6, 36.1.1. IP address 36.1.1.3, 255.255.255.0. IP OSPF network 0.2 point and IP OSPF 1 area 2. Done. Let me access R6. Oh. Let me correct it. IP address 21.1.1.10.255.255.255.0. Then on which router I need to configure? R3. Yes. Config T, interface F1/0, no cert, and IP address 36 36.1.1.3 255.255.255.0 IP ospf network point to point and IP ospf 1 area 2. Write the configuration, then go to router number 6 and interface f1/0 and no cert and IP address 36.1.1.6 255.255.255.0 IP ospf network point to point and router ospf 1 router ID 6.6.6.6 exit interface f1/0 and IP ospf 1 area 2. Soon it will form ospf neighborship, so IP ospf neighbor done, and so IP ospf database. It is learning all 50 prefixes in the form of LSA3 and there are 2 LSA1. Save the configuration and let me create one loopback here. Interface loopback 1 IP address 60.1.1.1 255.255.255.0 IP ospf 1 area 0 and IP ospf network point to point. Save. So IP route ospf. So IP route ospf. See, I'm learning all 50 prefixes. That means I'm getting all branch 1 prefixes, right? On router number 10 also I'm going to create one loopback, which is my new company. Interface loopback 1 IP address 10.10.10.1 255 not 10.10.1.1 255.255.255.0 IP ospf 1 area 3 and IP ospf network done. Now guys, branch 1 can communicate with branch 2. Yes, to verify it, simply let me take you to R5 and from R5 so IP route ospf. You can see I am learning 60 network. No, why we don't have 60 network information here? So IP ospf database. Let me troubleshoot it. Go to R1 and on R1 so IP ospf database. I will check which summary LSA of area 0. Here we don't have 60 networks. Then go to router number 3 and on router number 3 so IP ospf database. Here you can see for area 0 we have LSA3 and in this LSA3 60 network should be there, but 60 network is not there. So simply directly go to router number 6 and so IP ospf database. So here is the router LSA of router 6. Let me open the router LSA of router 6. So IP ospf database and router LSA of 6.6.6.6. 60 network is there, right? Then why it is not advertising to their neighbor? So IP ospf neighbor. How to troubleshoot? So IP ospf interface f0/0 include network. So IP ospf interface f0/0 ospf is enabled on loopback, correct? So IP ospf interface f0/0. What happened? ospf not enable. Sorry, I am saying on 0/0. It should be 1/0. Include network. Network type is point to point. Network type should be same on router number 3 also. So IP interface f1/0. So IP ospf interface f1/0 and say include network. Network is point to point. So IP ospf database. This is the ospf database of router 3. Here we should have 60 network in the LSA 3 of area 2. So where is LSA 3? Here is the LSA 3 of area 2, and here we have 60 network information. Correct? Now it's fine. On router 3 will advertise it to router number 1. So let me take you to R1, and router 1 have multiple ABR router now. So IP ospf border router, you can see router 2 is also ABR, router 3 is also ABR, and cost to reach both ABR is 1. So IP ospf database, and this router should learn 60 network in the form of LSA 3, in the form of LSA 3 of AS0. We don't have 60 network information here. What is the issue? This is for area 1. Area 0, area 1, area 0 LSA, router LSA, network LSA, area 0 LSA, then area 1 LSA. In the area 1 LSA, in the area 2 LSA, there is some, I think, misconfiguration of area to show IP ospf border router. This border router belongs to which area, guys? Area 0, correct? Then why I don't have 60 network information here? Again, let me take you to R3. Tell me how to troubleshoot it. Just use your brain. So IP ospf database of router 3, 60 networks. 60 network is there in area 2, correct? But we don't have, I think, any summary LSA for area 2 on router number 1. Summary LSA for area 2. Okay, I got the reason. Now tell me, what is the reason, guys? Why we don't have 60 network on router number 1? And on router number 2 also you can check router 2 database. So IP ospf border router, now you can see 3.3.3 is also ABR, and so IP ospf database. Even 36 network is not there. 36. So IP ospf interface brief f1/0. Border router 6.6.6. What it's saying, router 3 is saying 6.6.6 is also ABR. Is it true? Is router 6 ABR? So the issue over here is, you can see on router number 6. So IP ospf interface brief. What is the issue? I have advertised this loopback in area 0. Right? So let me correct it. Interface loopback 1, say IP ospf 1 area 2. Say Done. Now go to router number 1 and see show IP ospf database. Done. Now you can see 16 network. Got it? LSA1, LSA2, LSA3 all are clear, and now let me verify the connectivity from branch office 1, means from router number 5. I'm going to ping, let's say, which branch? Branch 2 users. Ping 60.1.1.1 and say source 50.1.1.1. Will ping work? Is ping working? Yes, ping is working. Trace route 60.1.1.1, source 50.1.1.1, numeric. See how traffic is going. Router 5 is forwarding traffic to router 1. Router 1 is forwarding traffic to router 3. Router 3 is forwarding traffic to router 6. Done, guys. Now let me configure router number 4 here. Router 4. Interface F1/0. No set IP address. Between router 4 and router 7, 47.1.1.4, 255.255.255.0. Here I am not going to enable ospf routing protocol. Which protocol I will enable here? EIGRP. So I have to use network command here, router EIGRP S number 10, and network. Which network? 47.1.1.0, and say no auto summary. Done. So IP EIGRP interface. So you can see EIGRP is enabled on F1/0, right? On F1/0, routing protocol is EIGRP, and on F0/0, so IP ospf interface brief. On F0/0, protocol is ospf. So this router will become which router? So IP protocol. Which type of router it is? Yes, very good. Where is the information? Where is the information? There is no information of ABR. The reason, until and unless you will not perform redistribution, this router will not become ASBR. See, right now EIGRP and OSPF, both routing protocol are running on router number 4, and both are maintaining their separate database, right? EIGRP have their own database, OSPF have their own database. We have not redistributed anything from EIGRP into OSPF, so that's why this router is not ABR router. Also, will perform redistribution on any router. Also, will perform redistribution of any protocol in OSPF on any router. That router will become ABR. So guys, how to redistribute? And before redistribution, let me configure router 7, router 8, and router 9. So let's start from router number 9. On router number 9, interface F1/0, no set, and IP address. Between router 8 and router 9, let me use 89 network. 255.255.255.0. Exit interface loopback 1, IP address 90.1.1.1, 255.255.255.0. How to enable RIP routing protocol? Router RIP network 0.0.0 version 2, no auto summary. Save the configuration. Now let me take you to R8, router 8. On router number 8, interface F1/0, no set, and IP address 89.1.1.8, 255.255.255.0. Exit interface F0/0, IP address between router 7 and router 8, 48 network I am running. 78, sorry. Between router 7 and router 8, I am going to use 78 network, 78.8.0. 8 255.255.255.0. Here I cannot use network command 0.0.0 because one interface belongs to RIP, one interface belongs to EIGRP. So router RIP version 2, no auto summary network. Which network I will advertise in RIP? 89.1.1.0. Do so IP RIP database. So we have only 80 network. Why it is not receiving? Look back. So IP RIP database. It have installed 90 network. Soon it will share with their neighbor. Done. I have received 90 network here. Do so IP route RIP. You can see it have installed the 90 network in the routing table. And now let me configure EIGRP. Router EIGRP S number is 10 and network 78.1.1.0. Say no auto summary. Now guys, here we need to perform redistribution, RIP into EIGRP and EIGRP into RIP. So tell me first how we'll perform redistribution here. In the RIP, redistribute EIGRP S number 10 and metric. Metric in RIP is hop count. So let me define metric 5 here, then exit. Router EIGRP S number 10. Redistribute RIP. And how EIGRP calculate metric? With the help of K values, right? So K1. Then load. Sorry, delay. Then load. Reliability. MTU. Done. So IP EIGRP topology. See, it have installed 90 network in their topology table. Now I am going to close the console of router 9. I have saved the configuration. Let me save it first again. And now let me close the console of R9. Router 8. Save. And let me close the console. Go to router number 7. Config T. Interface F1/0. No cert and IP address. Between router 4 and router 7, I am running 47 network, 47.1.1.7, 255.255.255.0. Exit interface F0/0, say no cert. And here guys, network 78.1.1.7, 255.255.255.0. Exit. Can I run 0.0.0 command? Network 0.0.0? Yes, because all interface belongs to same routing protocol. Say no auto summary. So IP route EIGRP. Just wait. So IP EIGRP neighbor. So we have neighborship with router number 4 only. So IP EIGRP interface. So IP EIGRP interface. EIGRP is enabled on both router. Yes, here on F0/0 we don't have any peer. What happened? So IP EIGRP interface. EIGRP is not enabled. So run section EIGRP. Router EIGRP S number 10 network 78.0.0.0. That is fine. So IP interface brief. IP is 78.1.1.8 and I am advertising same network. Then why we don't have neighborship here, guys? This interface is administratively down. Interface F0/0, say no cert. That's it. These are troubleshooting while configuring. Sometimes you need to troubleshoot the network as well. Someone is waiting, I think. Don't know why you are joining class now. So IP route EIGRP. Done, guys. See, I'm learning 90 network here and this is external network EIGRP. Now let me close the console of router 7 as well, and let me take you to router number 4. And on router number 4 also we have EAGRP neighborship. So IP route EAGRP. I have some EAGRP routes here, right? And so IP route ospf. We have some ospf routes here. Now we need to redistribute ospf route into EAGRP and EAGRP route into ospf. So first let me do one thing. Router EAGRP ES number 10 and say redistribute ospf process 1. And again, whenever you will redistribute any routing protocol prefixes in EAGRP, you have to define key values. Then delay, load, reliability, MTU. Now I need to redistribute EAGRP into ospf. Do so IP EAGRP topology. You can see it have installed all ospf prefixes in their EAGRP topology table. That means now it will advertise to router number 7 to their neighbor, router 7 will advertise to router 8 will advertise to router 9. Even on router number 9 we can verify it. So IP route RIP. So you can see on router number 9 we have all ospf prefixes, means all branch 1 prefix, branch 2 prefix 60 network, as well as branch 3 prefix, which is, where is the branch 3 prefix? In the branch 3 10 network. Why we don't have 10 network here? So IP route 10.1.1.0. This network is not in table. Again we need to troubleshoot, go to router number 2 and so IP route 10.1.1.0 not in table. Go to router number 10 and say so IP ospf interface brief. Ospf is enabled on loopback interface. So IP ospf database. So let me check the router LSA of this router. Database router and 10.10.10.10. So this on this router, in the router LSA, it have this network 10 network information. Let me take you to router number 2 now, and on router number 2 so IP ospf database router, and I want to open router LSA of 10.10.10.10 in detail. Here you can see 10 network is not there, right? In the database of router 2 we don't have 10 network information. How to troubleshoot it? So IP ospf neighbor, we have neighborship full, but if you have ospf neighborship and you are not receiving the route, first you should check network type. So IP ospf border router, let me check border router as well. Okay, that is fine. So IP ospf interface F 1/0 include network. Network type point to point, and on router number 10 also so IP ospf interface F 1/0 include network. Network type is point to point. Now why this router is not advertising 10 network to router number 2? So IP ospf interface brief. Loopback is in which area? In area 3. And F 1/0 is in which area? Area 2. And on router number 2 so IP ospf interface brief. F 1/0 is in which area? Area 3. So every here on router number 3 think is correct. On router number 10 we have wrong configuration. So go to interface F 1/0 and say IP ospf 1 area 3. Save it. Now go to again router number 4 and directly on router number 9, and let me check the table. Still this router don't have route. Now you can see router 9 have received the 10 network, right? Branch 3 network information. Done, guys. Done. Now I am going to advertise redistribute EAGRP into OSP upon router number 4. So let me take you to R4 again and say router OSPF 1 this time, and redistribute EAGRP ES number 10. And how OSPF calculate metric? Cost is the metric. So here you can give the number, or you can even leave it. You can ignore it. We will discuss the redistribution, don't worry. For now I am just defining metric 10, that whenever this router will redistribute EAGRP prefixes in OSPF, it will advertise that prefix in OSPF domain with metric 10. Now, so IP protocol. This router is ESBR, Autonomous System Border Router. And now if you will check the database, you will have one new type of LSA. Actually, you will have two new types of LSA this time. So IP, yes? Hello? Any question? So IP OSPF database. Now let me open the database of router 4. So IP OSPF database. See guys, router LSA of area 0. Network LSA, LSA 2, DR router is generating. Summary LSA, LSA 3 of area 0. All border routers, ABR routers are generating, router 2, router 1 and router 3. Right, to advertise inter area prefixes. Now see the new LSA, which is LSA 5, correct? Which router is generating this LSA? 4.4.4.4 ESBR. So LSA 5, which is external LSA, will be generated by ESBR. Why? To share external prefixes in OSPF domain. Getting my point? See, with the help of external LSA, LSA 5, it is sharing these network information. And you have one more LSA, that is LSA 4. Now let me take you to router 5. Router 5 is in area 1, and before that on router number 1 also, if you want to verify the database, so IP OSPF database. See, are you able to see the external LSA? Who is generating? And how many networks are there guys? These all external network. And again ESBR will advertise external prefixes with metric. If you want to open any LSA in detail like external LSA, we can say so IP OSPF database, then external, and then link ID 90.1.1.0. So it is advertising with what metric? 10, which I have defined while redistribution. Now how I can calculate metric to reach in this network, 90 network? Simply I can check cost to reach ESBR, because ESBR is advertising this network, advertising router ID 4.4.4.4. So in the external LSA, advertising router ID will be again the router ID of router who is advertising the network, and link ID will be the network information, right? So IP OSPF, so IP OSPF border router. Now you can see 4.4.4 is ESBR, and cost to reach ESBR is 1. Cost to reach ESBR is 1. Now LSA 5 can cross area, right? So router 1 is going to forward that LSA 5 to router number 5 also. Am I right? So let me show you the database of router 5 here. So IP OSPF database. Here you can see we have external LSAs, but the issue is now what? See how router 1 have get to know that router 4 is the ASBR, guys, with the help of EBIT in LSA 1. Once router 4 will become ASBR router, it will start ASBR. It will start sending LSA 1 with EBIT on. And once a router 1, router 2 and router 3, this router will receive LSA 1 of router 4 with EBIT on. It will get to know, okay, this is ESBR router. And then these routers are going to install LSA1 in their database. It will update their database, but LSA1 will not cross the area. Then how router 5 will get to know where is the ESBR. How router 10 will get to know where is the ESBR. How router 6 will get to know where is the ESBR router. So that's why now your AVR router is going to generate LSA4 to share router information of ESBR, right? So on router number 5, if you will check database, let me take you to R5 and show IP OSPF database. You can see here you will have one new LSA, that is LSA4 summary ESBR. Who is generating? AVR router, AVR router. Why? To share the information of ESBR. To share the information of ESBR. All AVR router will generate LSA4 to share ESBR information. Done. So here you can see we have the information of 4.4.4. So this is how router 5 will get to know about the ESBR router. So IP OSPF border router. See, it have information that 4.4.4 is nothing but ESBR. This router have knowledge about the ESBR just because of this LSA4 generated by AVR router. Now let me ask the question, which router will generate LSA1? Tell me, guys. Which router will generate LSA1? All router. Which router will generate LSA2? DR. Which router will generate LSA3? Which router will generate LSA4? ABR. Which router will generate LSA5? ESBR. What is the use of LSA1? To share link state information. What is the use of LSA2? To share attached router information in the multi-access segment. What is the use of LSA3? To share inter-area prefixes. What is the use of LSA4? To share ESBR router information. What is the use of LSA5? To share external prefixes in OSPF domain. Is it clear? And now router 5 can calculate the metric because router 5 knew ESBR. So see, what is the cost to reach ESBR from router number 5? Cost to reach ESBR from router number 5 is 2, right? And so IP OSPF database, then external 90.1.1.0. The metric which is coming in LSA5 is 10. That means total cost to reach in this network is 12. So IP route OSPF, you can see for 90 network. For 90 network cost is 10 only. So now you have one new concept here, that why cost is 10 per full, cost should be 12. So we'll see this concept, guys, tomorrow. Now if anyone have question from the today class, please ask. Otherwise I will continue from tomorrow. Yeah. Yes, go ahead. to make communication possible between partner 2 network and this branches network to headquarter, how these companies can communicate with each other if you will not perform redistribution. At least don't ask this type of question. This is very basic, brother. Why we are redistributing two different routing protocol? Yeah, now I am expecting actually advanced questions from you guys, not these basic questions. Yes, anything else? Now we have some advanced concepts of ospf. I have covered all basic concepts. Like now we have to learn area concept. Area concept is pending, and then route filtering is pending. Some advanced concepts of ospf is pending, like why router 5 is calculating only metric, advertised metric by esbr, why it is using same metric, why it is not adding metric to reach esbr also, right? So router 5 is using what metric, guys, to reach in 90 network? The metric which esbr is advertising. Here is the 90 network, 90.1.1.0/24. Here I am redistributing this network in ospf with metric 10, and cost to reach esbr from router number 5 is 2. So total cost to reach in this network should be 12, but our router 5 have installed this network in their routing table with cost 10. So this is your question. Otherwise tomorrow we will see it. Then we have some route filtering, advanced redistribution in ospf. After that we will discuss some real-time scenario, like where we are using ospf, how we can perform path manipulation in ospf, how to perform load balancing in ospf, right? Those concepts. Then we'll move to the bgp routing protocol directly. Okay, so guys, please configure this topology, this all things, all types of LSAs by yourself in the topology. Even you can design any topology, not this topology only. You can create the scenario by yourself, like in the company, in the real time, what is happening. My main headquarters is connected with lots of data center, lots of branch offices. So you can assume that lots of branch offices are there. There is one data center, there is one headquarter office, right? Some partner network, partner company, and then configure the multiple routing protocol there. Okay, guys, that's all. Bye. Let me save the configuration of each device, otherwise I have to reconfigure tomorrow. Router 9 saved, router 8 saved, router 7 saved, and let me